Pandas in Python, not an animal pandas, is derived from the panel and data. It's an open source BSD license library providing high performance, easy to use data structure and data analysis tool for the Python programming language. For more detailed document, along with the tutorial and other resources, can be found at the following URL. For installing and using pandas, we must use the instruction import to import the pandas. And when you have installed pandas, you can use this instruction to check the version of your pandas. So you can, like the NumPy, you can import pandas using the PDS and ls. So you can use the instruction import pandas as PD, and then you can use the instruction or function in pandas use PD dot. In the pandas, we have two kinds of object. One kind is one-dimensional series, another is two-dimensional data frame. The pandas series object is a one-dimensional data array, dimensional array of index data. So important is the series is one-dimensional array, and contain another information is index about the data. It can be created from this array as follows. So here we create the panda series from a list. Okay, so here a list with 4 numbers, and we have not assigned any index corresponding to the list. So the list is originally from 0 to 3. So we can see the data is a series. Here is the content of the data, and here is the index about the data. So the value are simply fair to NumPy array. So if we want to find the value about the pandas series, we can use the dot value to access the NumPy array behind the used to present the data about the series about in the pandas. For the index in an array-like object, we can use the type PD index. So here, if we type the PD index, we can access the index about the series. So here, this is data, dot value. The value will access content of the NumPy array, and we can use dot data dot index. We can get the index about the series. So like with NumPy array, the data can be accessed by associated index by the favorite Python square bracket notation. So here we have a series like one. This contains the series and the index of the series. We can use square bracket notation to access the index, and we can access the index give a range to access series inside a range. So here we can access the data, the index 1, column 3. So we must note that the interval will not contain this number. So it is number 1 and 2. Okay, so the NumPy array has an implicit defined integer index used to access the value. Okay, implicitly we don't need to assign the index because the index also is from beginning 0, 1, 2, 3. Okay, so we don't need to assign the index. So NumPy array has an implicit index. Okay, and the pandas has a series explicitly defined the index associated value. So here, for example, we have the pandas data like this one is created by the panda series corresponding to this list, and we can assign the list index. So we can create the pandas series like this one. For each value, we have an index. Here we can see the index not 0, 1, 2, 3. And we can assign new value, new name to the index. So this value, the index with A and B and C, D. So we can use the same as the index to bracket the name of index to access the value. So we can access data V. So here data V is 0.5. Okay, well, we can even use non-continuous or non-sequence index. So here we use the same. We can use the same list to create a NumPy series with index 2537. So this index not continuous, it's not sequential. Okay, so we can create the NumPy series as one. So we can see here the index not continuous and non-sequential. So here we can access data 5. For the data 5, by access the series, use the index 5, so we can access the number 0.5. Okay, so actually, we can consider a series as sometimes like dictionary because we can access the variable index by the access the content of series by the index. So we have a mapping from the index to the value. Okay, so next is we can map the value in the dictionary. We can make the key to the value. Okay, so here we can define a dictionary like this one, and we can create series from this dictionary. If we create the series use dictionary, then here the key is the index and the value is the content about the series. So if we have the series population like this one, we can dictionary style item access can be performed. So here population in California, we can get the data about population of California. So here is this value. Like additionally, although series also support array style operations such as slicing. So we cannot use slicing for dictionary, but if we use a series, we can use the array-like operation slicing. So we can slice a sub-series, or we can take sub-series for slicing the original series. So for population in California to Illinois, we can give the sub-series like this one. And we can construct a series object. Pandas series are constructed with some version of following. We can construct the PD series data. Here's data, and we can assign a series with some index. Here, index is not option argument. If we don't assign any index, the index is for 0, 1, 2, 3 to n. And the data can be one of many entities. For example, data can be a list of NumPy array, in which case the index default an integer sequence. So here we create pandas series 2, 2, 4, 6, and originally the index 0, 1, 2. And the data cannot be a scalar, which is repeated to fill the specified index. So here we can just create series 5, just one number, but the index with three number 100, 200, and 300. So we can create the series with three elements, and the elements will send a value 5. And data can be a dictionary in which index default to be stored the dictionary key. Okay, so we can create the series from a dictionary. So the index is key, and the content of the series is value about the dictionary. So in each case, the index can be publicity set if a different result is performed. So we can set here is can control addition here, but for the series we just select index 3 and 2. So we just select index 3, this element and this element. Just select these two elements from this dictionary. So the pandas data frame object, we have this is a two-dimensional array. So for one-dimensional array is we could discuss previous is series. For two-dimensional array is in the pandas is data frame. So a data frame is two-dimensional array which both flexible row index and flexible color name. Okay, so data frame is generalized NumPy array. So we can control the data frame from the dictionary. So here if we have dictionary like this one, and we can control the series from the dictionary. And here we can type the content of area from the dictionary as this one. And another, now we have two series. One series is population and other area. Use a dictionary to construct a single two-dimensional object. We can control. So here we control the data frame. The data frame contains two series. One series is population, and the other is area. So we can construct a two-dimensional data pandas data frame. Use this syntax. So here we have a area and the first series, and another is a population. Is another series, and this two series has the same index state. So we can control the data frame use the two series. And we can type the series, the data frame. Okay, that is one. So type the state index. Okay, state for this data frame. The index for the data frame is California, Florida, Illinois, New York, Texas. So we can type the state index, and we can give the result for the index about the data frame. So state column, what is state column? Actually, state column is the name of the column. Sometimes we can consider this a field or attribute about the data frame. So here, state column, we have received the index. The index is a list about the name of column. So the data frame can be thought of as generalized two-dimensional NumPy array, where both the row and the column have the generalized index accessing the data. So here, the data frame we can consider the data frame as specialized dictionary. Data frame make a column name to a series of column data. So here we can say the state is the data frame, and we assign the name. Here we can access the series, or we can access the column in the data frame. And we can must to note that in a two-dimensional NumPy array, the data there will return the first row. Okay, but for data frame, the data column 0 will return the first column. Okay. So for single series object, we can control the data frame from an object. So we can control the data frame from the single series object. Actually, this data frame just contain one column. And we can control data frame from object, for example, from a list of dictionary. So we can control the dictionary here. Here is a dictionary where we have I, this index from a follow I in range 3. So we have a I value from 0, 1, 2. And for 0, for value I equal to 0, then the dictionary is A mapping to 0 and B mapping to 0. And I is 1, then this dictionary A mapping to 1, B mapping to 2, and when I is 2, A maps 2 and B maps to 4. So we can control a data frame like this one. And even if some key in dictionaries are missing, Pandas will fill them in with NaN. What is NaN? That is not a number. Okay, so Pandas we can control here. Here we have two dictionary, and this dictionary the key is A and B, and this dictionary with keys B and C. So for the first dictionary, without the value about C, and for the second dictionary, without the value about A. Okay, so we can see we will generate the position with mixed data. The Pandas will fill this position with NaN, not a number. Okay, so we can control data frame object from a dictionary of series object. Okay, so here we can see the PD data frame control from two series, and we can obtain the data frame like this one. And we can control data frame object from two-dimensional NumPy array. If we have a two-dimensional NumPy array, and we can give the name of index and name of columns and the name of index, we can create data frame. So here we can generate a random number with 3 by 4, 3 by 2. This is 3 by 2. So we can control a NumPy array. This is random number, two-dimensional random number with 3 by 2. And we can assign the columns and the index by this. Okay, and we can control data frame object from NumPy structure array. So here we can assign the np.zeros. We can create a NumPy array with zeros, 3 zeros. Okay, and the data type is A, and F8, B, and F8. So we can control the NumPy zeros, okay, with 3 elements. Each element is a tuple, okay, a tuple with D type, A, and less than I8, B, less than F8. So if we print out the content of data frame, we can see the result like one. So the index object is an interesting structure itself, and it can be thought of either as an immutable array or an ordered set. Okay, typically a multiple set an index object may contain repeated value. So we can construct an index from a list of integers. For example, okay, pt.index 2, 3, 5, 7, 11, and we can print out the content of index. An index is an immutable array. Okay, so we can we can access the content of index. Index 1 will be 3, and the index colon 2 is 2 and 5 and 11. Okay, so we can access the content of index use the CMS for list or for NumPy array. We can print out index size, index shape, index dimension, and index type. So one difference between index object and the NumPy array is that indexes are immutable. That is, they cannot be modified by the normal means. So we cannot change the value about the index. If we want to change the value of index 1 be 0, then we will get an error message. So the index are actually the index as order set. So if we have an index A and index B, we have two indexes. So we can make the intersection. Okay, A and B, we can make an intersection. So we can see the index is an ordered state. So we can make intersection about these two sets and the union symmetric difference for the index.